Okay, just let me remind you what we discussed last session. We started with sustainability. This is the second part. I will finish it, and next session, hopefully next week, inshallah, we will start with solar energy, the first source of energy, and the technology used to capture this energy. And we will design system, we'll use formula, we will do technical and economical analysis, and many other engineering aspects. But to complete the story here regarding sustainability, you remember I mentioned in my last session that for sustainability we need to satisfy three targets or points. These are the social, economic, and environment. And let me talk today about the environment and how we can measure it. As you know, it's not enough to solve engineering problem, any type of engineering problem, without considering cost and economic cost and, or let me say, economic side view and environmental side view. I mean, we may manufacture, let me say, a chemical plant or electrical plant, but without considering the environmental issue, will not complete the story, and something will be missed all the time, and we may lose rather than we get revenue. Example, if I come to electrical plant and I use, let me say, nuclear plant, but I didn't consider the hazards coming from it, the radiation coming from it. Especially, I want to make this plant in a city, in the center of city. This is not acceptable. The same thing could be said for environmental issues related to chemical plant. Chemical plant, as example, near Sohar area, near Sohar city, we have to consider carbon dioxide emission and other pollutants. Without considering this is make our decision, our planning is not clear and not correct. How we can judge this? We need equation at the end. As an engineer, I need equation to judge my system in terms of environmental impact. There is well-known equation called EPAT equation. EPAT, as you can see here, let me bring my pen. Okay, EPAT, I for impact, P for population, A for affluence, and T for technology, which tell me that our project, whatever project or problem we solve, okay, to measure the impact, our impact on the environmental, we can do it by multiplying the population, the affluence, and the technology. Definitely, we need to reduce the affluence as much as we can. We don't want to consume our resources. And at the same time, we need to improve the technology. We need to consider this. How many people will affect by my, let me say, project is an issue needed to be considered. Here I show you cover page for my book, Renewable and Sustainable Energy Principles and Applications. You will find some information related to it. I advise to read about it more. Also, there are many websites available in internet. You can use them to see examples for using EPAT equation. But one issue before I go for the environmental and economic aspect and our systems and the scenario facing humankind and the challenges, I would like to mention that regardless of your specialty as an engineer, you are environmental engineer because our technology, our production, our problem we solve will affect direct or indirect the environment. So we are, let me say, affecting the environment by our activities, and as an engineer, technology, if I produce any material, any equipment, then I take resources, artificially I convert them into something else, losses and waste coming from my production. So at the end, I'm hurting the environment. Now, what are the possibilities and outcomes in terms of environment and economic systems? We have a few options. The first option, as you can see, I call it here continuous growth. We keep grow, more people on the planet, more industry came, more equipment came, but this will end in a point of time due to the limited world. We have limited resources, limited plant, so at the end we are going to stop somewhere. Another option is control approach to equilibrium. It means sustainability. This is what you are looking for. We need to improve the technology. We need to solve our problems as an engineer in industry, in organizations, at home, using what we learn in our specialty. But we have to make it more sustainable to reach the equilibrium and to control things. Overshoot and oscillation. This is with our, let me say, decisions. We will see that sometime overshoot coming in one side or another side, we need to dump it, and fluctuation keep going, overshoot, dumping. But this is not easy task. I mean, some of them possible to be controlled. As example, the climate change, we cannot control it. It's happened. We can reduce its effect by taking some decisions, but we cannot control it. We need to consider something else. Overshoot and collapse, this is the end. I mean, we want to avoid being in this situation that overshoot happened in our ecosystem, in economic system, in social system, environmental system. We need to, let me say, avoid reaching this point. Now, this will lead to three scenarios facing humankind. Okay, the first scenario, we call it the standard run. From the name, we keep running as we are. We change nothing. Okay, the same activities, the same consumption of our resources, the same pollution we are emitting to the environment. As you can see here, the results will be, see, irreversible environmental change occur, which is what we call it climate change. Hot places will be cold, cold places will be hot. We will destroy the, let me say, water life. We will reduce the, we will see that many disasters happen here and here, cyclone, tsunami, and so earthquake, and we will see that the depletion of many food resources will be soon and appear. Invest capital depreciation faster, as I mentioned, then it can be rebuilt. As it fail, food, health, service will be fail, death rate increase, and life expectancy reduce. You can see this clear in these statistics taken from IEA, International Energy Organization, organization, where they put here expectation from 1900 into 2100. We are 2020. As you can see here, these are my parameters, A, B, C, D, E, represent resources, population, pollution, food, industry. And from the other side, the lifestyle will give life expectancy, service per person, food consumption. Okay? We can see that here in the middle, which is around 2020, last year, things will go down. You see all of them, they are going down. This means that the resources start to deplete, population reduced, pollution, only maybe pollution will be increased, food, industrial output, things going down because we continue in the same standard without changing, without taking any action to reduce our activities' impact on the environment, on the world. Now you may say, okay, give me example about this. Let me first try to prove for you that our activities affect the environment. Have a look. This is well-known curve. This is give the atmosphere CO2 concentration and temperature change. Okay. Yeah. This curve is this curve represents the CO2 concentration, and the green one represents the temperature change from the past. You see here thousands of years ago. From, let me say, today, 150,000 years ago. If you compare the two curves, and you are an engineer, you know that there is correlation here. There is a relationship between temperature change and the CO2. This means that any increase in CO2, as we are doing now for the last 100 years, temperature will increase. And you may say, okay, even so what? If the temperature increases, what will happen? What will happen? Ice will be melt, environment will be changed, more heat will be captured between the earth surface, water and land, and the atmosphere, and this will change everything. Will create, let me say, what we call it climate change and global warming. We are going to discuss this at the end of the semester. So if we keep increasing CO2 coming from our activities, temperature will increase and we change everything on this planet and we may lose control. So back to my point, which is continue in the first senior standard run, continue in the same trend will lead to change things. When we talk about atmosphere temperature, this is nature. We change the nature, and this will reflect on many sectors in our world, food sector, energy sector, water sector, and so on. Now you may say, okay, can we do something? Yeah, we have many things to do. Examples, as two examples are energy efficiency. We improve energy efficiency. Energy efficiency can be improved by improving the technology, by improving the way how we build our buildings and houses, okay, to reduce the consumption. As example, in a new building, you may use insulator, okay, to make sure that you keep the cooling inside the house and you don't need more cooling. Or in another example is using double glazing for glasses and shadow for windows and many other, let me say, options we can use to improve efficiency. I will mention to some of them at the end of the semester in energy conservation. Material also efficiency, we can improve it because you know what, when we would like to manufacture anything, we use raw material. Now from this raw material, how much we lose, what is the waste, are going to use as example 20% and we lose 80%. Can we improve this and reverse it? Okay, because we want to reduce the waste. Reducing waste will increase efficiency, material efficiency. The second scenario is technical solution. Some people think that we can solve any problem technically by using knowledge, okay? And to have this, let me show you the assumptions and the results. If we assume from 1995 that double resources at the start, we double the resources used. Well, this is not a good option. Pollution to be controlled, efficiency to be controlled plus 3% per annum, per year. Land productivity plus 2% per year. Reduce land erosion 3 times, and industrial resources efficiency increased by 3% per year. Okay, what is the result? Okay, our results will be 1, population growth continuous with food supply just maintained. Quality of life will stop and decline from 2020, but definitely slowly. And at the end, technology will not solve the problem because we keep declining. I will show you the graph. See the graph. This is 2020, around approximately. You see, you flattened in some places, okay? But later on, it will go down because, as I mentioned, we live in a limited world. Resources are limited, planet is limited. And the same thing here. Yeah, we flatten it rather than it's with overshoot in the standard scenario. It's get flattened in this way, but at the end it would go down. So we didn't solve the problem. Now, before I go for the third scenario, I would like to mention that while you are working in a project, finally project, try to use this formula. See some examples and apply it to your project. See how your project, let me say, interact with EPAT equation. what is the impact of your project on the environment, on the population, on the affluence, and the technology. And also, one of the way to check the, let me say, the economic aspect is to use what we call it GNP. GNP is gross national product. Gross national product, okay, is simply a parameter, or let me say index, okay, or key performance indicator. We use it to judge the lifestyle quality in a country, and it's calculated by calculating all the incomes of the citizens inside and outside the country minus the foreign people inside the country, their incomes. Okay, now this GNP example I will give here in this table. See GNP here. I will compare Kerala, India, and US. Now, when we compare Kerala and India, they are so close to each other, even India a little bit more. But comparing both with US, it's high. Their GNP is high, which tell me that the lifestyle here, the quality of lifestyle here is higher than here in India and Kerala. But simple improvement happened in adult literacy. They educate women in Kerala. We see that here they educate them more than India. This reflects positively in life expectancy. It's increased compared with US, and here less, and reduce this element, which is good. 17 infant mortality compared with US, while here it is high. So just simple, sustainable improvement in anything, in anywhere in our world will make difference. Let's learn how to make difference. Let's learn something good and add it to our knowledge in engineering and make our system more sustainable and more developed. Okay, now third scenario, and the last one is, we call it accept having enough. Okay, this assumption here, we will make some assumptions. The first assumption is 2 children per family. Reduce the number of children. It is difficult even in this area, in this region, but still we need to think about reducing the family members. Okay, affluence is enough 350 per capita industrial output, and technology, the same previous one, would multiply by 2. Now let's see what will happen. Until at least 2100, population stabilize 7.7, because you know, when people increase, the resources consumed fast, more pollution came, more problems created, and they start fighting on the wealth and resources. Comfortable standard of living and high life expectancy and pollution will be reduced. So we are part of the problem. We create, humankind create the problem. The pollution, most of it coming from our activities. If we admit this and take action to reduce it, to add sustainable development to our systems, then this will reduce the impact of our activities on the nature, on the planet, on the environment. Can we do it? There are many challenges. By the way, before I go to the challenges, you see the curve now is stable, linear. You can see here it's linear for the parameters. We can go for it if we decide to take this scenario. Now we have a few challenges. We need to address them while we are working to sustainably develop our activities, our project, our solutions. The first one is we need to define the progress. As example, we need to put formula. We need to put theorems and the procedures, how we can measure the progress on the level of sustainable development. The other one Economic market technology failure, we need to learn how to deal with it. I will give examples here. There is economic crazy occurred in 2008. In 2014, it is again occurred. Even if the reasons are not the same, but still it occurred, and the humankind did, or the markets and the societies did not recover yet from 2008. In 2020, last year, another crazy economic crazy occurred. How we deal with this crazy? How we can solve the problem? Because when economic crazy occurred, okay, people lose their jobs, and the fresh graduates and youngs will find difficulty in get job opportunity. We need to know how to solve this. We need to know how to deal with this. Social dimension, as I mentioned, is the complicated one in sustainable development. How we define it, how we measure it, what are the criteria. This is different from project to project, from product to product. We need to address this one also. And another point is understanding and engaging with real world complex system. Interaction in our system, learning more about our world, about our universe will solve problem, because there is proximity principles. If we don't know what is our world, what are the problems in our world, if we don't have enough knowledge, as we can see now for this pandemic, coronavirus pandemic, we found ourselves that we don't have enough knowledge how to deal with the problem, how we solve it in short time. Okay, what are the barriers? What are the points motivate scientists or communities to collaborate? This is something new for us. We need to know more about our world. And differences in time scale, as you know, there is different in time scale between politic and commercial, let me say, side view, and the real world and the lab. Even for the lab and the industry, there is a gap, at least 110 years. I mean, we may discover something in a lab and we need 10 years to commercialize it. We need to reduce this gap to fasten the transfer from lab to the industry. These are the main challenges we face in sustainable developments. I will stop here, okay? If you want to save Earth, become an engineer. We solve the problem, we create part of the problem, but we can't solve the problem, the whole problem, and save our environment and our planet. I will stop here. Do you have any question?
No, Dr.
Okay, next. Thank you very much. Next session, we will start with solar energy, equations, techniques, methods, approach, and calculations. We will have examples. We work together on this. And I think Ms. Moza already started with you. I will continue with this part. Let me stop here. Thank you very much.